We are continuing our series talking about induction motors. What are we going to be talking about today?
We're going to talk about the difference between brake horsepower and rated horsepower of an induction motor.
So what's the opportunity here with these horsepowers?
Well, it's really important to understand the difference between rated horsepower and brake horsepower when you are designing systems. I mean, the mechanical engineer has to understand this, but eventually the electrical engineer gets into this, and so that's why we're going to talk about it.
What is the difference between rated horsepower and brake horsepower?
Well, I think the best way to describe it is the automobile analogy. If you buy a car with a 200 horsepower engine, it's rated for 200 horsepower. But you don't drive at 100 miles an hour constantly up a hill using a full 200 horsepower. You use whatever horsepower is needed for the load. And the brake horsepower for a motor is exactly that. It's the horsepower that's actually being delivered to the load at any given moment. Because a motor simply delivers what load it's asked to deliver. It doesn't deliver its rated horsepower unless it's asked to do that.
Where did the term brake horsepower come from?
Well, that's a great question, and it takes me back to 1973 in my University of Washington motors class, and there was a contraption there that was a motor. It had a flat wheel on it, and around the wheel was wrapped a metal band, and then to the metal band was a handle, which we put a stress gauge on, or a pressure gauge, and we could adjust the pressure. So we effectively could brake the motor, and that's where the term brake horsepower came from, because we were measuring the horsepower using this brake. Now, the math for calculating all this is interesting, but not important for what we're talking about. You're simply converting the forces and the leverages and the friction and the torque and the RPM with a whole bunch of units conversions, and you get horsepower. Fun, but not what we're trying to do today.
For the power, you could multiply the amps times the volts to get the power. Why don't we do that?
They're related, but not precisely. First of all, the amps have an imaginary component, which is not power at all. It's imaginary. And so when you're in the anything you measure in the current and multiply times the voltage, you get the kVA or the volt amps, but you don't get the power. The other thing is the motor has an efficiency, and what you're wanting to look at is what's actually delivered to the load, and motors have a wide range of efficiencies, and so some of that energy that's going in that you would measure as amps is actually just going into heat in the motor windings. So that's why you can't just use the amps. And there's a curve here which shows you that as the motor is coming up to load, the power factor changes. And so the relationship between the current and the power is not precisely following in a linear fashion to be useful. Now, if the manufacturer measures all these characteristics and gives you a table, well, then you can use the amps. But otherwise, you can't just use them without all that information tested.
Is the brake horsepower always the same for a given motor?
Well, if you go back to what the brake horsepower is, it's a function of the load. So no, it's a function of the load, not the motor. The rated horsepower is when you take the brake horsepower up to a point where the current in the windings matches the full load current. The current is chosen for a motor based on the heating effect and the temperature that the windings get to, because at the end of the day, it's the insulation that's going to break down if it gets too hot. And so you can only take the current up to a rating that the insulation can handle. And that's pretty much how the rated horsepower gets set for a motor. And of course, this is all based on not stalling. You can't oversaturate the magnetic elements of the motor and stall.
What happens when the loads increase beyond the rated horsepower?
Well, first of all, the motor gets warmer, just simply gets hotter. And because you get I squared R, the heating effect in the motor. And you're allowed to go over the rated current or the rated horsepower a little bit on some motors. There's a term called the service factor, and that will be printed on the nameplate. And a typical service factor is 15%. So you can take a motor and run it 15%. Well, you can take it to what the service factor says, and it may not be 15%. It may not have a rating at all for service factor. But if it does, it's okay to take the motor to that level, but it'll cut down on the life of the motor for sure because it's going to be running hot.
How does the electrical designer use the rated horsepower and the brake horsepower in their design?
Well, ironically, the National Electric Code handles this directly with Table 430.25, for example, for three-phase motors. Actually, there's several tables there in Section 430, and the National Electric Code actually prescribes the amps for each rated horsepower that the engineer has to use. And the reason was explained to me this way is that the first motor that goes in may be of a certain efficiency and it may have a certain load on it, but the next motor that goes in maybe came from another source and has different characteristics. And so the National Electric Code said, well, just to keep everything conservative, here are the amps we want you to use for any given rated horsepower. And that's, from a practical standpoint, how the designer deals with these horsepowers and the circuits that they're serving.
All right, so let's review what we've talked about with brake horsepower today.
Okay, brake horsepower is the actual load on the motor, not the rated horsepower. And the term brake horsepower, again, simply comes from the arrangement of the test system where they put a brake on the motor and measure the horsepower as the force of the brake increases. The rated horsepower is simply the maximum brake horsepower that is recommended for long life of the motor. A service factor is sometimes allowed for a motor to give you a little extra room to increase the horsepower output, but it's not recommended as a design point.